At Sandvik, manufacturing is based on recycled steel and purchased alloy materials. We buy high-quality scrap only from certified suppliers. The raw material is analyzed and any harmful ingredients are carefully removed. The scrap's melted at 1600 degrees centigrade in an electric arc furnace. In the argon-oxygen decarburization vessel, carbon content is reduced to stainless steel levels. Exhaust gases from furnaces and AOD processes are filtered to cut pollution, and the dust thus extracted is further processed for metal recovery. The chemical composition of the melt is closely monitored throughout the process to meet our own demanding standards. We make continuous analyses to guarantee the correct steel grade and ensure traceability and consistency between the batches. The results are entered in a form that accompanies each batch through every stage of the process. After pre-rolling of continuous cast material or ingots in the blooming mill, billets are transported to a heating furnace to be reheated to the correct rolling temperature. The billets are then rolled in Sandvik's modern rolling mill, where round and square billets are rolled to a wide variety of sizes. The new mill provides quick product dimension changeover, short lead times, energy savings, and excellent product quality. The mill is integrated with the blooming mill to form one continuous production line. Billets and bars are rolled to finished size in 1 to 6 passes. Cut into requested lengths. The bars are inspected before dispatch or put through further internal processing. Full traceability is maintained throughout the manufacturing process. Before the bar steel is used for tube manufacturing, its chemical composition is confirmed in a spectrometer test. To prepare extrusion billets, the bars are peel-turned, cut, and deep bored. The extrusion billet is heated to about 1200 degrees centigrade, and then lubricated internally, as well as externally with a glass powder. A mandrel is inserted into the hole in the billet. When extrusion begins, the billet is pressed out between the die and the mandrel. Resulting in a seamless tube that can be delivered directly without further processing through cold working according to customer specifications, or used as the starting point for further processing. The extruded tubes are rapidly straightened and pickled in acid to remove glass and metal oxides. After deburring, dimensional checking, and inspection, the tubes are ready for final production. Following visual inspection and X-ray spectrometry, the tubes pass through the Pilger mill. To re-establish material structure and hardness, the tubes are then heat-treated in an annealing process. They're heated to over 1000 degrees centigrade in a protective atmosphere to avoid oxidation. And then rapidly cooled to about 300 degrees. The tubes are straightened, polished, and thoroughly cleaned. According to customers' requirements, the tubes are fully inspected for defects using ultrasonic and eddy current testing methods, set to detect the tiniest defects such as cracks, cavities, or other material defects that the naked eye can't detect. Their dimensions are verified, and they're also checked to ensure they're free of intermetallic phases. This is followed by visual inspection. The destructive testing stage includes flaring, flattening, and tensile strength tests. Corrosion and microstructure properties are also verified. Such tests are crucial to ensure the material meets customer specifications. The tubes are stored in Sandvik's fully automatic stockroom, from where they're eventually selected, packed, and loaded onto trucks for further distribution to their final destination.